Hello everyone, welcome to our tutorial video. I'm Kata and Enikő is here with me. Hello Enikő.
Hi Kata, hello everyone.
In today's video, we will explore functions that are essential for creating a mechanical plan. Enikő, what exactly does this mean? Can mechanical engineers now design in the program?
Since the program is mainly used by architects and interior designers, its goal is not mechanical design, but visualization, where it is very effective.
So, if as designers we receive a completed mechanical plan from an engineer, we can import it into the program?
Yes, and this helps us plan how to aesthetically hide the mechanical system.
What will we create today?
We will begin visualizing a ventilation system and demonstrate all the key functions needed for conceptual mechanical visualization.
How is this ventilation system structured?
It consists of a central ventilation unit connected to supply and exhaust fans. The program helps represent this system with minimal manual work. And we can do even more. You will see that the objects we use contain a lot of information which can be displayed on the floor plan.
What objects are we talking about?
The ones we will use were downloaded from beamobject.com. These objects already include the necessary data to function as components of a mechanical system.
So, they can do more than regular objects?
Yes, let's see this in action. First, we need a heat recovery unit, which is the central component of the system. I saved the downloaded object in the map content folder, and now I will place it. I previously created a ceiling, and I will move the unit above it. Let's check what extra information this object contains. On the left, we can see all its connectors listed, each with assigned properties, like whether it supplies or extracts fresh air. From here, we can also start drawing pipes. The program automatically recognizes the required pipe type and begins drawing with it.
I see that the connectors are numbered. Do we need to remember what each one does, or is there an easier way?
There's an easier way. If we zoom in close enough, each connector displays its assigned property and diameter. If we need more details or want to change a property, we can access its settings with this button.
How does the system work in practice?
The central unit draws in fresh air, distributes it through the house via various fans, then extracts the used air and vents it out, in this case through the roof. We can see that this connector is responsible for fresh air intake. Click on its marker, select a new element from connector, and start drawing the pipe outward. We can place its endpoint by entering a value or clicking at a point. Press Enter when done to stop drawing the pipe.
Now let's create the exhaust pipe. This needs an elbow connection. Does that make it harder?
Not at all. The program automates this. We start drawing the pipe horizontally, click to place a point, then choose to add the vertical segment, define its length, and confirm. As you can see, the elbow is automatically placed and matches the pipe's cross-section.
What's next?
Now we need to place the supply and exhaust fans in the rooms and connect them with the pipe system. Since the process is the same for each, I will demonstrate it with just the supply fans. I will find the object I need and place it in the room.
How should the connector be orientated?
I will rotate the connector toward the center of the room, since that's where the ductwork will go. Each room gets a fan, and larger rooms will have two. Mechanical objects have a special marker that provides extra functions not available for other objects. We will use these later. First, I will define the main duct path using rectangular pipes. I will lay it across the house, keeping some space from the fence for connection elements.
The system is currently open-ended. How we can close it?
We can close it by clicking the pipe's endpoint and adding an end cap.
How do we connect the pipes to the fence and the central unit?
For this, we need branch fittings, placing one at each connection point. These are available under the Fittings menu.
What happens if we choose the wrong pipe size?
If I try to place a round fitting on a rectangular duct, the program won't allow it. It detects the compatibility issues.
What about size adjustments?
No need. The program automatically matches the fitting size to the pipe. Now I will place all the T-branches aligning with the fan outlets.
Let's start by connecting it to the heat recovery unit. Does the different cross-section cause issues?
Not at all. We can place a transition fitting. Click the T branch as the starting point. Define the other pipe's cross-section manually or by selecting from the floor plan. Draw the pipe to a certain point and turn it as needed. Adjust for height differences using a flexible connector. The program automatically adapts the piping. This process needs to be repeated for each fan.
How do we create the exhaust system for used air?
It's nearly identical, except we place exhaust fans instead of supply fans, and we connect the system to the exhaust connector of the central unit. Since the steps are the same, I won't repeat them.
Okay, is there a quicker alternative for manual connections?
Yes, there is. Instead of manually placing each pipe, we can use AutoConnect. Place the transition fitting. Select AutoConnect, click the connector, and the program does the rest. It automatically generates the pipe path and adds necessary fittings.
Is there anything else you would like to show us about this topic?
One more thing. If the mechanical system becomes complex, adjusting the 3D view helps with clarity. Instead of rebuilding the entire model, we can set the map view as primary to keep mechanical elements always visible, or show only the map elements for better focus.
Thank you, Annika. That is it for this video. I hope you learned many useful things today and have fun with ARCHLine.XP 2025. Bye!
Bye!